Here we have a geometry problem on two-column proof. Okay, let me go the given information. It is given that D is the midpoint of the line segment AC. Line segment BA is congruent to line segment BC. And the third information is angle measure EDA is congruent to angle measure FDC. Using these given information, we have to prove that the triangle AED is congruent to triangle CFD. Okay, we can prove this stuff we have over here using the two-column proof. Before that, I have to plot the given information on the triangle we have over here. Okay, now let me consider the first information, that is D is the midpoint of the line segment AC. So the line segment AC is over here, and the question says D is the midpoint. Since D is the midpoint, it will divide the line segment AC into two congruent line segments. That is the line segment AD and the line segment CD are congruent. Because D is the midpoint of AC and it divides the line segment AC into two congruent line segments AD and CD. Okay, now let me consider the second information we have over here. That is the line segment BA and the line segment BC are congruent. So line segment BA is over here and the line segment BC is over here. So both of them are congruent. Let me mark it over here. So BA and BC are congruent. Okay, now let me go to the third information, that is angle measure EDA is congruent to angle measure FDC. So we have angle measure EDA is over here, this angle measure, and this is congruent to angle measure FDC, it's over here. Okay, now I have plotted the given information on the triangle we have over here. Okay, now we can start proving that the triangle AED is congruent to triangle CFD using two-column proof. Okay, now let me write the required stuff. Here I have taken two columns. In the first column I am going to write the statements. In the second column I am going to write the reasons. Okay, now let me write the given information as statements over here. Let me take the first information, that is D is the midpoint of the line segment AC, and also the line segment BA is congruent to line segment BC. And angle EDA is congruent to angle FDC. So all these statements we have in the question itself, that is these are all given information. So the reason we have to write, that is given. Okay, now let me consider the stuff we have over here in this triangle. That is a line segment AD is congruent to line segment CD. Okay, let me write the stuff over here. Line segment AD is congruent to line segment CD. So how can it decide that line segment AD is congruent to line segment CD? Because D is the midpoint of the line segment AC, that's given in the question itself, and always the midpoint will divide the line segment into two congruent line segments. Let me write this one as a reason. So here I have written the reason of why the line segment AD is congruent to line segment CD. So because D is the midpoint, it divides the line segment AC into two congruent segments AD and CD. Okay, now let me consider the second information, that is the BA is congruent to BC. That is a line segment BA over here is congruent to line segment BC. Okay, now let me consider the complete triangle ABC. In this triangle ABC, the sides AB and the sides BC are congruent. Okay, now let me consider the interior angle measure at the vertex A over here and the interior angle measure at the vertex C over here. Okay, these two interior angle measures are opposite to the two congruent sides. That is, the interior angle measure of the vertex A is opposite to the side BC, and the interior angle measure of the vertex C is opposite to the side BA. Already we know that the sides BA and BC are congruent. Since the two angle measures over here are opposite to the two congruent sides of the triangle, so these two interior angle measures must be congruent. So we can write the interior angle measure at vertex A over here as angle EAD. Let me write it over here, angle EAD. Actually, this is congruent to the interior angle measure C. So the angle measure at the vertex C can be written as FCD. Let me write it over here. This is congruent to angle FCD. What reason do we have to write for this statement? That is, angle EAD is congruent to angle FCD. So the same what we have discussed so far, we have to write over here. That is, angles are opposite to congruent sides. Let me write the stuff over here. Congruent sides are congruent. Let me write it over here. So that is, we know that angle EAD is opposite to the side BC and angle FCD is opposite to the side BA. Already we know that the line segments BA and BC are congruent. Since these two angle measures are opposite to the congruent sides, so they must be congruent. So this is why we have decided that angle EAD is congruent to angle FCD. So we have written the reason over here. Okay, now let's consider the three parts in the triangle AED over here. That is angle measure A and angle measure at the vertex D. And AD is the side included by these two interior angles of the triangle AED. And also we can consider the same stuff in the triangle CFD over here. That is angle measure over here, angle measure over here, and the side we have over here. And this side CD is included by these two angle measures. Already we know that angle measure we have over here at the vertex A and angle measure we have over here at the vertex C are congruent. And this angle measure and this angle measure are congruent. And also we know that the line segment AD and the line segment CD are congruent. So the two angles and included side of one triangle are congruent to two angles and included side of another triangle. Whenever two angle measures and included side of one triangle are congruent to two angle measures and included side of another triangle, then the two triangles are said to be congruent by angle side angle triangle congruence postulate. Okay, now let me write the vertices of these two triangles in order. Okay, now let me write the vertex A of the first triangle. Let me write it over here. First, let me write the triangle symbol. So I have taken vertex A in the first triangle. What is the corresponding vertex in the second triangle? That is C, because the interior angle measures at vertex A and vertex C are congruent. Let me write it over here, C. Now let me take the vertex C in the first triangle. What is the corresponding vertex in the second triangle? That is F. And now let me take the third vertex D of the first triangle. The corresponding vertex in the second triangle is also the same D. Let me write it over here. So these two triangles are congruent by angle side angle triangle congruence postulate.